Hello there, and welcome. I'm so glad you found your way here tonight. Maybe your thoughts have been restless lately, looping through headlines and to-do lists. Or maybe you're just someone who finds comfort in the sound of impossible questions. Either way, you've arrived at the right place. You don't have to do anything now. No goals, no plans, just breathe. Let your body soften into the quiet. Let your mind drift outward, past the ceiling, past the sky, into the deep velvet dark where even starlight begins to fade. Because tonight, we're not looking at the stars, we're looking beyond them, past every galaxy, past every particle, past the last whisper of space itself. Tonight, we travel to the very edge of everything and then ask the question that has haunted scientists and dreamers alike. What lies beyond? This isn't a quest for certainty. It's a journey into wonder, a slow, luminous exploration of the unknown. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Our first stop lies at the very boundary of reality itself. When we talk about the edge of the universe, it's easy to imagine a boundary, a wall, or a final frontier stretching out until there's nothing left but a black curtain and silence beyond. The human mind likes edges. It likes fences and finish lines, the clear moment where something ends and another thing begins. But the universe is not a box, and it doesn't sit inside anything. There are no corners to reach, no glass dome to press your hand against. The universe isn't expanding into space. It's space itself that's expanding, stretching, carrying everything with it, like ripples spreading across an endless pond. When you look far enough in any direction, you're not seeing toward a wall. You're seeing backward in time, toward the earliest light that ever managed to reach us. That light, faint and ancient, forms what astronomers call the cosmic microwave background. It's the soft afterglow of the Big Bang, still humming across the sky more than 13 billion years later. Beyond that glow, the light has been stretched so thin by expansion that it can no longer reach us. That faint boundary, the limit of what we can observe, is sometimes called the edge of the observable universe. But it isn't an edge in any physical sense. It's more like the edge of sight when you stand in fog. The landscape doesn't end where the mist begins. It simply becomes hidden from view. Imagine inflating a balloon. Dots drawn on the surface drift farther apart as the balloon swells, but the surface itself has no edge. There's no outside to reach from within the balloon's skin. The universe works a bit like that, though on scales too vast to visualize. Every galaxy moves away from every other not because they're sailing through space, but because space itself is stretching between them. To someone in another galaxy, it would appear that we are the ones moving away. There's no privileged center, no outer rim, just the same expansion unfolding everywhere at once. If you could somehow travel at the speed of light in a straight line, you would never reach the universe's boundary because there is none to reach. Instead, you might find yourself curving back toward where you started, not because space is looping like a racetrack, but because gravity and geometry can bend the fabric of reality itself. The universe may be infinite, or it may wrap around in ways we can't yet measure. Either way, the horizon we see is only a small bubble in a much larger, perhaps boundless, sea. The observable universe spans about 93 billion light-years across, a number so enormous it defies ordinary comprehension. Yet that figure doesn't describe the whole. It describes the distance to the farthest light that's had time to reach us since the beginning. Beyond that, galaxies continue, silent and unseen, their light still on its way, or forever lost to the expansion that outpaces it. Those regions are as real as the stars above you now, but they will never be visible, no matter how powerful our telescopes become. The universe hides its greater self behind a veil of time. It can be unsettling to realize there's no outer wall, no edge to crash against. We like containment, the comfort of borders. But in the cosmic sense, the absence of an edge is the deepest kind of freedom. It means that existence doesn't sit inside anything, it simply is. Every direction you look, you peer into a different past. Some of the light that touches your eyes tonight began its journey before Earth had formed. Before atoms in your body existed, you are literally seeing time stretched into space. The expansion itself is accelerating. Distant galaxies recede faster and faster, carried outward by something we call dark energy, a mysterious pressure woven into the fabric of the cosmos. One day, their light will slip beyond our cosmic horizon entirely. The night sky will grow emptier, its stars fading not because they've gone out, but because their light can no longer bridge the widening gulf. Future observers, billions of years from now, might see only the nearest galaxies and believe the universe ends there. Every age carries its own horizon, its own temporary edge of understanding. And so, when we ask where the universe ends, we are really asking about the limits of our perception. The edge is not a place but a boundary of awareness, a line drawn by the speed of light and the age of time. What lies beyond may be more of the same, more galaxies, more voids, more endless structure, or something so different that our language has no shape for it. Perhaps there is no beyond at all, only the continuation of a pattern without repetition, infinite and self-similar, like a dream that refuses to wake. The next time you step outside on a clear night, think about how the darkness overhead isn't empty but full of unreachable places. Every star is a fragment of a larger whole, every glimmer a message from the deep past. You are standing on a small world, adrift in an expanding ocean that has no shore, surrounded by distances that will never stop growing. The edge of the universe isn't out there waiting to be touched. It's the line where curiosity meets infinity, where our desire to see collides with the truth that some things will always remain beyond sight. And somehow, that's what makes it beautiful. When you look out into the night sky, you're not seeing space as it is now. You're seeing it as it was long ago. Every pinpoint of light is a memory, a relic from the past, still traveling toward you through the dark. Some of those photons have been moving for billions of years, crossing a changing universe, slipping through expanding voids, bending around gravity wells, until finally, impossibly, they find your eyes. The farther you look, the older the light becomes, until, eventually, you reach a distance so immense that time itself begins to warp. Beyond that, there is a wall you cannot see but can only imagine, the cosmic horizon, the farthest edge of visibility, not because there's nothing past it, but because light beyond that line will never reach us. It's a limit not of space, but of time. The cosmic horizon is the ultimate reminder that seeing is not the same as knowing. To gaze across the universe is to look backward, tracing history like ripples in a pond after the stone has long sunk. Every extra billion light years deeper into the cosmos is another billion years further into the past. Look far enough, and you see galaxies as they were before our planet formed. Keep going, and you approach the glow of the cosmic microwave background, the faint afterlight of the Big Bang itself. Beyond that glow, the curtain falls. The expansion of space stretches light faster than it can travel, and photons that once might have reached us are now forever stranded in a universe rushing away. It isn't darkness that stops us. It's the speed at which the universe itself is expanding, carrying those distant regions beyond reach. Imagine that space isn't a void, but a fabric, constantly stretching. The galaxies are like points drawn on a balloon that's being inflated. As the balloon grows, the points move apart, not because they're traveling across the surface, but because the surface itself is expanding. Now picture a point on that balloon so far away that, no matter how fast light tries to move toward us, the balloon's expansion pulls it farther back. That's the cosmic horizon, a point of eternal retreat. It's where distance and time stop making sense in the way we understand them. The light there isn't slow, it's loyal. It's been running toward us for almost 14 billion years, but space keeps adding more distance beneath its feet. Even the phrase "farthest we can see" is misleading, because the horizon isn't a fixed line. It's an evolving one, shifting with time, shaped by expansion. Every second that passes, light from slightly closer regions finally reaches us, joining the great mosaic of the visible universe. But in the same moment, countless other places slip beyond our horizon forever. Their light too weak, their distance too vast. The cosmic horizon breathes, expanding and receding at once, a living boundary drawn by the geometry of space-time. To look toward that horizon is to look into a paradox. You're seeing something that no longer exists in its original form. The galaxies you glimpse at the edge of observation have already moved billions of light years farther away by now. Their light left them long before Earth was born. Some of them may have merged or faded, their stars burned out, their shapes unrecognizable. But their ancient light still arrives here, whispering a story written in a language of distance and delay. The universe you see is an echo, not the present moment. We live surrounded by ghosts of starlight. The concept of an event horizon isn't unique to the universe itself. Black holes have them too, regions where gravity is so strong that not even light can escape. The cosmic horizon is like that, but on a scale so vast it encompasses everything. It's not gravity that holds light back, but expansion. Beyond it, reality continues, but forever outside our ability to know. The universe may be infinite, but our access to it will never be. We are bound by time as much as by distance. And yet, the idea that there's a limit doesn't make the cosmos smaller. It makes it more mysterious. It turns every star, every beam of light, into a gift that somehow outran eternity to reach us. The photons arriving at this very moment have traveled through epochs of creation and destruction, through cold and heat, through emptiness and radiation, through collisions of galaxies and births of stars, all to end their journey here. In your brief moment of awareness, you are part of their destination, the final surface they touch before dissolving into memory. So when you stare into the dark sky, remember that the darkness itself is not empty. It's filled with light, too faint, too far, or too stretched to see. Somewhere beyond that invisible wall, new galaxies are forming, stars are igniting, entire civilizations may rise and vanish, all without their light ever crossing the gulf. The cosmic horizon is not the end of the universe. It's the edge of our story, written in the ink of time and distance. Beyond it, everything continues, unobserved, but not unreal. The expansion keeps unfolding, space keeps stretching, creation keeps echoing outward into an infinite unknown. And here we are, on one small planet, looking up, catching ancient light on the surface of our eyes, thinking about a place we can never go. That invisible horizon is the most honest border in existence, a reminder that even the universe, in all its vastness, still keeps secrets. There are galaxies out there whose light will never reach us, not because it's too faint, not because it's too far, but because the universe is expanding faster than light can bridge the distance. Imagine that for a moment. Entire realms of stars, billions of them, locked forever beyond the horizon of visibility. They exist, they shine, they move, but their light is trapped in a race it can never win. Every second that passes, more of the cosmos slips away from us, not into darkness, but into unreachable time. It's not that the light is lost, it's that space keeps stretching between us and the source, faster than that light can ever travel. In the early universe, distances were smaller. Light could cross the gaps between galaxies, weaving them together in a shared conversation of energy and gravity. But as space expanded, as dark energy began to accelerate that expansion, those conversations began to fade. The wavelengths of light stretched too, pulled longer and redder, their colors shifting toward the edge of invisibility. This is what astronomers call redshift. the stretching of light by the growth of the universe itself. It's not motion through space, it's space changing beneath the motion. When you look at a distant galaxy, the red tint in its light is not a trick of color, it's a message. It tells you that space has been expanding all the while that light has been traveling, that the distance between you and that galaxy has grown unimaginably wide since the light first left it. Some galaxies are so far away that their redshift is infinite. That means their light, no matter how long it travels, will never arrive. The expansion of space pulls them away faster than light can move forward. It's like trying to walk up a down escalator that accelerates beneath your feet. You can keep climbing forever and never make progress. The universe has regions like that, running ahead of light itself. To imagine those places is to imagine silence, not because nothing happens there, but because nothing from there will ever reach here. In that sense, the universe is not a single visible object. It's a patchwork of overlapping horizons, each centered on an observer. Every galaxy, every star, every planet has its own cosmic boundary beyond which it can never see. From our perspective, we can observe roughly 46 billion light-years in any direction, but beyond that, space continues without end. And in those unreachable distances, there may be galaxies larger than ours, clusters vaster than any we know, whole superstructures of stars folding into patterns we'll never witness. They are real, but permanently invisible. Even now, light is leaving those distant places, just as it has for billions of years, but space is expanding faster than the light can cross. That means the photons traveling toward us will never arrive. They will stretch, weaken, fade, until their energy dissolves into the background hum of the cosmos. What we call the edge of the observable universe isn't the end of creation. It's just the place where light has lost the race. Beyond that, existence continues silently, like a song played on frequencies our ears will never hear. If you could somehow freeze the expansion, if you could stop the acceleration and wait long enough, all that hidden light would eventually reach us. But the universe doesn't slow down, it speeds up. Dark energy, the mysterious force driving this acceleration, grows stronger as space expands. The more the universe stretches, the faster it stretches still. This means that as time passes, more galaxies cross the line into invisibility. One day, billions of years from now, even the galaxies we see today will vanish from view, their light redshifted into nothingness. The night sky will grow empty, leaving only the faint glow of our own galactic neighbors. To those future observers, the universe will seem small and still, even though it will be larger than ever. There's something strangely tender about this inevitability. The universe is always saying goodbye to itself, losing touch with parts it once could see. But it doesn't stop expanding, doesn't stop creating, doesn't stop glowing beyond its own horizon. The light that never arrives still exists somewhere, frozen in its impossible journey. It travels endlessly, carried away by the swelling of space, caught between motion and stillness, presence and absence. It's a perfect metaphor for longing, the kind that stretches across lifetimes, never reaching its destination but never ceasing to try. And yet, we're lucky to see as much as we do. Every photon that reaches us is a survivor of impossible odds, a tiny victory against eternity. The light from a distant galaxy may have left before Earth had oceans, before atoms in your body even existed. When that ancient light finally brushes your eyes, it completes a story that began before time had meaning. The photons that fail to arrive are countless, but the ones that do are miraculous enough. So when you look at the sky and see a star, you are witnessing something that began long before you, something that might already be gone, something that still arrives despite the pull of forever. The galaxies beyond sight still burn, still spin, still dream in silence. The universe is full of light you will never see, but knowing it's there, knowing it's racing endlessly through the dark, is its own kind of wonder. Some light never reaches us, but in the vastness of everything, even unseen, it still matters that it shines. In the beginning, there was no light. Not because it was dark, but because there was no space yet for light to travel through, no time for it to move within. The universe was smaller than an atom, denser than anything the human mind can imagine, a storm of raw potential compressed into something infinitely tiny. And then, in less than the blink of an eye, everything changed. Space didn't just grow, it erupted. Time began. The universe expanded not at the speed of light, but faster than light itself. In the first trillionth of a second, it inflated from subatomic to cosmic size, stretching smooth and wide, laying down the invisible foundation upon which every galaxy, every star, every moment of your life would one day unfold. This instant, this brief flash of impossible acceleration, is what scientists call cosmic inflation. It was not an explosion, though it's often described that way. Explosions have centers, edges, directions. Inflation was everywhere, all at once, space itself multiplying within itself. It's as if reality took a deep breath and exhaled existence. There was no before and after in any ordinary sense. There was only expansion, an awakening that rewrote the meaning of distance. Within that single instant, quantum fluctuations, tiny ripples in the energy field, were stretched across vast scales, seeding the unevenness that would later become galaxies, stars, and eventually, you. Before inflation, the universe was a seething foam of quantum chaos, where energy and matter flickered in and out of being. During inflation, that chaos was ironed flat, like wrinkles smoothed from a cosmic sheet. The process erased irregularities, cooled temperatures, and connected every distant region of space to every other. That's why, billions of years later, when we look at the cosmic microwave background, the leftover radiation from the Big Bang, we see remarkable uniformity. The same temperature, the same glow, spread evenly across the sky. It's a quiet fingerprint of the moment the universe began to breathe. But the most extraordinary thing about inflation is what it implies. If space could expand faster than light, it means parts of the universe were torn away from one another faster than even information could travel. Those regions are now so far beyond our cosmic horizon that we will never see them, not even in principle. They exist forever outside the bubble of our observable reality. To us, they are gone, but to themselves, they are still part of the same unfolding cosmos. Inflation didn't just make our universe, it may have made countless others, each born from the same process, each expanding into its own horizon, each forever separated from the rest. The laws of physics don't forbid this. In fact, they hint that inflation might never have truly stopped. That even as our patch of space slowed and cooled into stars and galaxies, other regions kept expanding, faster and faster, endlessly budding off new universes like seeds carried by a cosmic wind. In this view, the universe we know is just one bloom in an eternal field, in a single flare of creation, in a landscape where inflation still roars on, birthing unseen realms beyond any distance we can imagine. The multiverse, if it exists, began right here, in that first moment of runaway growth. To understand how strange this is, think of time as a surface, smooth and taut. Inflation didn't just stretch that surface, it created it. It gave time its direction, its flow. Before it, there was no before. The arrow of existence itself began there. Every second that has passed since the rise of stars, the cooling of worlds, the evolution of life unfolded from that first immeasurable instant. The space between your breaths, the pause between your thoughts, all trace their ancestry to that singular burst of expansion. You are made from what inflation left behind, and still, the echoes of that moment remain. Tiny quantum ripples frozen by inflation shape the pattern of galaxies we see today. Those ripples, microscopic fluctuations in energy, became the scaffolding for everything visible in the cosmos. Without them, there would be no stars, no planets, no atoms that could come together to form the cells in your skin. The structure of the universe, from the vastest cluster of galaxies to the smallest grain of dust, is a memory of that trillionth of a second. It's almost impossible to comprehend how something so brief could define everything that followed. But that's the nature of beginnings. They don't last, yet they leave marks that never fade. Inflation was the universe's first heartbeat, a moment when nothing turned into everything and space itself learned how to grow. And even now, billions of years later, the universe hasn't stopped expanding. The same process that once stretched it beyond comprehension still hums quietly beneath reality, driving galaxies apart, deepening the voids between them. If you could watch the universe then, it wouldn't have been a fiery explosion but a silent blooming, an instant of pure motion without noise or color. It would be invisible, incomprehensible, overwhelming. But within that motion lay every possibility that would ever exist. The songs of stars, the gravity that binds them, the light that someday would find your eyes. Inflation didn't just build the cosmos, it built the space for wonder itself. And somewhere, beyond all sight, inflation may still be happening. Somewhere, new universes may be unfolding even as you breathe, their light destined never to reach us, their beginnings echoing the same silent surge that once gave rise to ours. Creation never really ended. It only moved beyond our view, carrying the story onward, faster than light can follow. If you could step far enough back to see the entire universe at once, you might expect to find curvature a great cosmic arc, bending around itself, like the surface of a sphere. For most of human history, we imagined the heavens that way, a dome overhead, a bubble enclosing all existence. But when scientists measure the geometry of the universe with instruments so sensitive they can detect the faintest ripples in ancient light, what they find is astonishing. The universe is flat, perfectly, impossibly flat. Not flat like a sheet of paper floating in space, but flat in the sense that parallel lines never converge, that triangles add up exactly as they do on your desk, that light moves in straight paths across unimaginable distances without ever curving back upon itself. To call the universe flat is to say that its shape, on the largest scales, follows Euclid's rules, the same geometry taught to school children thousands of years ago. And yet, that simple word hides something profound. Because if the universe truly is flat, it might also be infinite. Not very big, infinite, but endless, without border or edge, without an outside to contain it. It means that what we can see, the observable universe, is only a tiny patch on an infinite cosmic plane that stretches forever in every direction. The faint glow of the cosmic microwave background, the afterimage of the Big Bang, reveals this with quiet precision. Its subtle variations, mapped by satellites and telescopes, tell a story written in temperature and symmetry. When scientists measure the patterns in that light, they find no sign of curvature large enough to fold space back on itself. Every data point whispers the same impossible thing. The universe, as far as we can tell, goes on forever. This flatness didn't happen by accident. In the earliest moments after the Big Bang, the universe could have been born with any shape at all, open, closed, or something in between. If it had been even slightly curved, that curvature would have grown more pronounced as the universe expanded, like a tiny bend in a balloon that becomes exaggerated as it inflates. But when inflation occurred, that brief burst of expansion, we now know, sculpted everything. The curvature was stretched out to near zero, smoothing space like a perfectly ironed sheet. It's the same reason a small section of Earth feels flat beneath your feet, even though the planet is round. Inflation magnified our tiny corner of the universe so enormously that its curvature became invisible, an imperceptible detail lost in an ocean of distance. And yet, flat doesn't mean simple. The universe is filled with invisible forces that warp and twist the path of light. Dark matter, bending space, galaxies clustering, voids expanding. On the grandest scales, however, these distortions balance one another. The average shape remains astonishingly even, like a sea that looks smooth from orbit despite its endless waves. To grasp this balance is to glimpse something almost sacred in its precision. The ratio of matter to energy, the density of space itself, had to be tuned with incredible exactness. A little more mass, and the universe would have collapsed back into itself. A little less, and galaxies could never have formed. The fact that we live in a universe that is not only flat, but capable of sustaining structure, time, and life is one of the most delicate coincidences in all of physics. When you think about infinity, it's tempting to imagine repetition, a cosmic grid of galaxies repeating endlessly, or copies of yourself scattered across space. But infinity doesn't need to repeat. It can contain infinite uniqueness. Every region of the universe could be entirely different, governed by slightly altered conditions, with its own patterns of stars, its own histories, its own variations of possibility. The idea of a flat, infinite cosmos doesn't just stretch our imagination outward, it stretches it inward too, forcing us to confront the limits of what a mind built for survival on a small planet can comprehend. You can walk around a globe and come back to where you started. But in an infinite flat universe, there is no return, no loop, no outer boundary waiting to be reached. There is only more. The light that paints our picture of the cosmos, the microwave background, the glow of distant galaxies can travel for billions of years and still not reach the end, because there is no end to reach. Somewhere, far beyond the observable horizon, new galaxies continue to form, stars burn and die, and light begins its impossible journey into a future that will never include us. We exist within one small bubble of perception, surrounded by an infinity we cannot touch or measure, yet one that quietly defines everything we know. Perhaps that's what makes this idea so strangely peaceful. The universe doesn't need to curve back toward itself or close like a story neatly finished. It can remain open, unbounded, vast beyond all imagining. When we look at the night sky and see only a thin slice of it, we are not looking at the limits of existence, but at the limits of our vision. The flatness of the universe is an invitation to wonder, a reminder that even the simplest shapes can hold infinite depth. And somewhere out there, beyond every galaxy and every horizon, space continues, smooth and silent, stretching onward without edge or center, carrying its stars like scattered seeds across eternity. The universe may be flat, but its meaning is anything but. Imagine space not as empty, but as an ocean, a restless sea of energy bubbling and frothing at the edges of reality. In that ocean, our universe is just one bubble, floating among countless others, each sealed off, each expanding into its own infinity. The air inside our bubble is everything we know: stars, galaxies, atoms, time itself. Beyond its shimmering wall, beyond the invisible boundary that separates our cosmos from whatever came before, other bubbles drift in the dark, each with its own physics, its own rules, its own story. Some might contain universes where gravity is weaker or stronger, where matter never forms, where light behaves in ways that would be unrecognizable to us. And some might look eerily familiar, almost identical, differing only in the tiniest of details. The theory of eternal inflation says that creation didn't happen once, it never stopped happening. The inflation that stretched our universe into being may not have ended everywhere at once. In some regions, that process of runaway expansion continues eternally, space still multiplying, still spawning new universes like soap bubbles forming in boiling water. Each new bubble begins as a fluctuation in the quantum field, a patch where inflation slows just enough for energy to condense into matter, for time to begin ticking, for stars to someday shine. But in the larger cosmic fabric, inflation goes on without end, generating bubble after bubble after bubble, an infinite foam of realities, each born from the same underlying vacuum, yet forever cut off from the others. If you could somehow rise above the entire structure, Not that such a thing is possible. You'd see not a single universe, but an endless froth. Universes budding like sparks from an eternal fire. Our own bubble is ancient now, its inflation long past, its galaxies drifting apart. But at its edge, beyond any horizon we could ever reach, space might still be inflating, faster than light, birthing new worlds we'll never know. Somewhere out there, another universe could be expanding alongside ours, separated by a gulf so vast that no signal, no light, no gravity could ever cross it. The border between them isn't a wall, it's a region where space itself expands too quickly for connection. It's not distance that divides these universes, but speed. The fabric of reality grows between them faster than anything can bridge. If you could watch these universes form, they might appear like luminous bubbles rising through a dark fluid, flickering briefly with creation before swelling into entire realms of space and time. Each one begins with its own version of the Big Bang, its own burst of expansion, its own physics determined by the quantum conditions at the moment it formed. Some bubbles collapse almost instantly, others inflate forever. The parameters of nature, the strengths of forces, the masses of particles, the shape of space itself could be different in each. Ours is simply the one where those values happen to allow complexity and life and thought. It's humbling to think that the laws we call universal may only belong to this one cosmic bubble. And though these universes can never touch, the idea of them brushing close has haunted physicists and dreamers alike. Some speculate that collisions between bubbles could leave scars, faint imprints in the cosmic microwave background, subtle distortions in the oldest light. Perhaps one day we'll find evidence of a cosmic neighbor, the ghost of another universe passing too near our own. Or perhaps not. Perhaps the other bubbles are forever hidden, expanding away faster than observation can chase them. To live in a multiverse is to live surrounded by unprovable mystery. But there's a strange comfort in that thought. It means creation wasn't a single fleeting act, it's a continuous unfolding. Even as our universe grows older, others are being born. Somewhere, new light is blooming. Somewhere, new laws of physics are being written. Somewhere, the first atoms of another cosmos are colliding, the first stars are igniting, the first minds are wondering if they too are alone. The multiverse isn't a theory of chaos, it's a theory of abundance, an infinite tapestry of beginnings, stitched together by the same invisible thread of expansion that once shaped our own sky. And in that endless sea of universes, our small bubble is still expanding, carrying everything we know along with it. Galaxies drift apart, stars burn out, civilizations rise and fade, all inside one fragile sphere of space that began as a quantum fluctuation in a larger, eternal storm. When you look at the night sky, you're peering through the walls of that bubble, out toward the void that separates us from all others. It's a humbling thing to realize that even our entire universe might be a single note in an infinite symphony, one brief shimmer in an ocean that never ends. Maybe every thought you've ever had, every word, every breath, is part of a moment that will echo only inside this one universe. And yet, that moment exists at all because somewhere in that eternal cosmic foam, inflation paused for the smallest fraction of a second and gave rise to this bubble we call home. It doesn't diminish our meaning, it deepens it. Because even if we are only one bubble among countless others, we are still here, awake, aware, and able to wonder about the ocean that surrounds us. If our universe is just one bubble in an endless cosmic sea, then somewhere, at some moment beyond memory, another bubble may have drifted close. Not close enough to merge, not close enough to shatter, but close enough to touch a brief, silent brush between entire realities. To us, that contact would look like nothing more than a faint irregularity in the background glow of creation, a cool smear in the otherwise perfect warmth of the cosmic microwave background. To physicists, those tiny variations might be whispers of something unimaginably vast, a scar left behind when our universe collided with another. The idea is almost too enormous to hold. Two universes, each its own self-contained reality, with its own space and time, expanding side by side through the inflating multiverse, eventually drawn near by the restless motion of that cosmic ocean. They never truly touch in the way objects do, because the surface of a universe isn't matter, it's the boundary of space-time itself. When those boundaries meet, their immense energies interact, rippling through both worlds, like waves passing through the same sea. The aftermath would be subtle but permanent, frozen into the radiation left over from the Big Bang. Billions of years later, we might still see its trace when we map the oldest light. That light, the cosmic microwave background, is a relic from a time when the universe was less than 400,000 years old, still glowing from its birth. It's astonishingly uniform. Its temperature varies by only a few millionths of a degree from one point to another. Yet scattered across that nearly perfect sky are a few odd cold spots, regions slightly cooler than the rest, wider than any single galaxy. Most of them can be explained by the ordinary clumping of matter or by the natural randomness of quantum fluctuations. But one in particular, deep in the southern hemisphere of the sky, is different. It's too large, too pronounced, and too strange to fit neatly into our models. Some scientists call it the WMAP cold spot, named after the satellite that first revealed it. Others call it something more poetic, a bruise. If the universe once collided with another, the energy of that contact could have rippled outward, altering the density of matter in its path. The region hit by that wave would cool slightly faster than the rest as the early plasma of particles and light began to settle. Billions of years later, when we finally looked back through telescopes and satellites, that cooled patch would still be there, faint and circular, like a fingerprint left on the face of time. It would be a reminder that our universe had once been touched by something beyond it, an echo of another cosmos brushing past in the dark. Of course, there are simpler explanations. The cold spot might be nothing more than a statistical quirk, a coincidence born from random fluctuations. It could be the shadow of a massive cosmic void, a region of space unusually empty of galaxies, stretching for billions of light years. But even the void itself, some argue, might be the ghost of that ancient encounter. The more we study it, the less certain we become. Science demands evidence, and evidence, in this case, is faint and patient. The cosmos doesn't give up its secrets easily. And yet, the thought persists, impossible to banish. If our universe really did collide with another, what would that mean? It would mean that the multiverse isn't just a mathematical abstraction, it's a living landscape, dynamic and restless, where universes are born, grow, and occasionally meet. It would mean that the boundaries between realities are not impassable walls, but flexible membranes, capable of influence, capable of touch. It would mean that our cosmic history is not isolated, but intertwined with histories we will never know. Perhaps, somewhere else, in another universe, beings are looking at their own ancient sky, seeing a faint, warm patch instead of a cold one, wondering about the same encounter from the opposite side. Two civilizations, separated by impossible distances and by the boundaries of existence itself, both gazing into the fossil light of a shared moment long gone. It's a haunting symmetry, the idea that even universes might leave memories of each other. We'll probably never know for certain. The evidence will always be just beyond reach, blurred by time and the expanding fabric of space. But maybe that's part of the beauty. The cold spot doesn't need to prove anything. It can simply remind us that the universe carries history in its light, that the afterglow of creation still holds unspoken stories. Somewhere in that faint microwave hum might be the echo of a collision older than time as we know it. When you stand under the night sky, think of that. Think of the ancient bruise faintly imprinted across the heavens, older than every star you can see. Think of the possibility that our entire universe once brushed against another and kept the mark, subtle but eternal. The cosmos might be infinite, but it is not untouched. Even among universes, there may be moments of contact, brief as a breath, leaving behind only a ripple in the glow of creation, a reminder that nothing, not even the universe itself, exists in perfect solitude. When we imagine the universe, we tend to picture it in three familiar directions: up, down, forward, back, left, right. Everything we know, from galaxies to grains of dust, lives within those coordinates. Space feels like an open field we can cross, an expanse we can look through. But what if beyond isn't outward at all? What if it's inward, hidden, not in distance, but in depth? Physicists have long suspected that the true shape of reality might include dimensions beyond the ones we can perceive, curled up so tightly that we move through them every moment without knowing. These extra dimensions don't exist beside us in the way another room exists beside yours. They exist within, woven into the fabric of space itself. They're not places we can go. They are the unseen architecture of everything. According to string theory, the smallest pieces of the universe are not particles, but vibrating loops of energy, tiny strings whose oscillations give rise to all that exists. Every particle, every force, every atom of your body is simply a different vibration of the same fundamental thread. For the math to work, though, the universe must have more than the 3 dimensions of space and 1 of time we experience. 10 dimensions, perhaps 11, are required to make the equations hold. The extra ones are hidden from view, curled up so tightly that they escape detection like microscopic folds in an immense sheet. Imagine an ant walking along a telephone wire. From far away, the wire looks one-dimensional, a simple line. But to the ant, up close, it's a cylinder. It has thickness, curvature, a whole hidden dimension wrapped around it. The universe could be like that, with unseen directions folded beneath the surface of reality. If you could somehow unfold those dimensions, reality would look nothing like the world you know. Forces that seem separate, gravity, electromagnetism, nuclear energy, would merge into a single unified field. Space and time would reveal themselves as vibrations on a deeper surface, the way sound ripples across a drumhead. In that picture, our universe isn't the whole drum, but one membrane, one brain, as physicists call it, floating within a higher dimensional expanse known as the bulk. Other brains may exist beside ours, stacked like invisible sheets of paper, each holding its own universe, its own galaxies, its own version of reality. And just as 2 sheets of paper can touch, 2 brains could one day collide, their contact igniting a big bang that gives birth to a new cosmos. Some theories even suggest our own universe began this way, a spark born from the impact of neighboring dimensions brushing together in the dark. We can't see these other brains, but they might brush against us in subtle ways. Gravity, for example, is far weaker than any other force. You can lift a paperclip against the entire pull of Earth's mass using just a small magnet. Some scientists suspect that gravity's weakness might be an illusion, that much of its strength leaks into other dimensions we can't perceive. If that's true, then every falling apple, every orbiting planet, every collapsing star is tugging not just within our universe, but across unseen boundaries of existence. Gravity may be the only messenger that travels freely between dimensions, a whisper from one reality to the next. The mathematics behind these ideas is dense and difficult, but the poetry of it is undeniable. Imagine entire universes hovering just beyond perception, separated not by distance, but by the limits of our senses. There could be countless worlds layered upon ours, their stars sharing the same coordinates, their matter passing through ours without interaction. Somewhere, right where you sit, there might be another sky, another history, another version of everything unreachable, unknowable, yet sharing the same invisible stage. If higher dimensions exist, they might also hold the key to mysteries we've long struggled to understand: dark matter, dark energy, the strange geometry of space-time itself. The hidden dimensions could influence the universe we see, shaping its expansion, curving its pathways, leaving faint traces in the patterns of galaxies and the afterglow of the Big Bang. Every time we measure a deviation, a subtle asymmetry, we might be glimpsing the shadow of something deeper, pressing through from beyond. The human mind wasn't built to picture more than 3 dimensions. We can model them, calculate them, even prove they must exist for the universe to make sense, but we can't truly imagine them. We're like flat creatures tracing patterns on a sheet of paper, unaware of the space above and below. Yet in those unseen directions, all of existence may unfold, endless and intertwined. And perhaps that's what beyond really means, not farther away, but closer than we can comprehend. The extra dimensions are not somewhere else. They're here, folded within every moment, every atom, every breath. You don't have to travel to find them. You're already passing through them. The universe is deeper than it appears, and within that depth may lie countless realities, vibrating softly in the silence, unseen but ever-present, an infinity hiding inside the ordinary. Across the vastness of the cosmos, everything is supposed to be moving away from everything else. Space itself is expanding, carrying galaxies along like leaves drifting on the surface of a widening pond. On large scales, this motion is smooth, predictable, almost serene. But when astronomers began to look closer, and really look, they noticed something that shouldn't have been there. A strange drift, a silent migration of entire clusters of galaxies, all streaming in the same direction, as if drawn toward some invisible destination beyond the edge of what we can see. They called it the dark flow. The discovery began quietly, with measurements of cosmic microwave background radiation, the ancient light left over from the Big Bang. Scientists use this faint afterglow as a kind of reference grid, a cosmic backdrop against which they could track the movement of massive clusters billions of light years away. By studying how this ancient light was slightly distorted as it passed through these clusters, researchers could infer their motion. What they found didn't fit the standard model of cosmology. The galaxies weren't drifting randomly, as expansion alone would predict. Instead, they appeared to be moving together, hundreds of millions of light years across, toward a single patch of sky, an unseen gravitational source that seemed to lie far beyond the observable universe. At first, the results were met with disbelief. The universe, as we know it, has no preferred direction. On the grandest scales, it should look the same everywhere. This principle, called cosmic isotropy, is one of the foundations of modern cosmology. But the data kept whispering otherwise. The flow wasn't small. Whole superclusters, vast webs of galaxies linked by gravity, were streaming at speeds exceeding 1,000 kilometers per second toward a region near the constellations Centaurus and Hydra. The signal was faint, the evidence uncertain, but the implication was staggering. Something outside the visible universe might be tugging on everything within it. If true, the dark flow could be a clue to what lies beyond our cosmic horizon. Our observable universe is only a bubble of visibility, defined by the distance light has traveled since the Big Bang. Beyond that, space continues, but it's forever hidden from us, its light too distant, too redshifted to ever arrive. Yet gravity, that most patient of forces, doesn't care about visibility. It reaches across boundaries of time and space. If there are massive structures beyond the horizon, clusters of galaxies, or something even larger, their gravitational influence could stretch across the unseen gulf and nudge the matter we can see. What we call the dark flow might be the faint pull of an invisible architecture beyond the edge of perception. There are theories, of course. Some physicists suggest that the dark flow is a relic of conditions before inflation, the period when the universe expanded faster than light, smoothing space and scattering everything beyond communication. Perhaps the region pulling us is a remnant of that earlier geometry, a fossil of pre-inflationary space pressing against the fabric of our universe. Others propose that it's evidence of the multiverse itself, that our cosmos is drifting under the gravitational sway of neighboring universes in a vast, higher dimensional landscape. In that picture, universes could interact like bubbles in an eternal foam, their gravitational fields overlapping just enough to leave faint signatures in the motions of galaxies. And yet, it's possible that the dark flow is an illusion, a statistical artifact, a coincidence born from limited data and imperfect instruments. Later observations from more precise satellites have struggled to confirm it, but the mystery endures, partly because the idea feels right in some deeper, almost poetic way. The notion that our universe might not be alone, that its motion could betray hidden neighbors beyond the veil of light, resonates with something ancient in us, the same curiosity that once made humans stare into the ocean and wonder what lands lay beyond its horizon. Even if the dark flow turns out to be a mirage, it reminds us that the universe is not as settled as it seems. Every observation we make is just a fragment of a greater whole, and sometimes the smallest deviations point toward the largest truths. If entire clusters are moving toward something unseen, then maybe space itself is not perfectly uniform after all. Maybe the universe has contours and depths we cannot yet imagine, shaped by forces older than time as we know it. It's a humbling thought that all the galaxies we can see, billions of them spread across the cosmic web, might be part of a grander motion towards something forever unreachable, a silent tide pulling everything, from distant quasars to the atoms in your body, in the same invisible direction. We will never reach the place they're headed. We can only watch the drift, measure the faint signals, and wonder what lies beyond the darkness pulling us onward. The universe is expanding, yes, but perhaps it's also flowing, and somewhere, beyond the edge of sight, something vast and unseen may be waiting, exerting its quiet pull on everything that exists, guiding the cosmos like a hidden current beneath an infinite sea. Between the bright threads of galaxies, where the universe seems to shimmer with infinite stars, there are regions of breathtaking emptiness. They stretch for hundreds of millions of light years, vast expanses where there is almost nothing at all. No clusters, no starlight, no dust, no whispers of warmth. These are the great cosmic voids, the silent lungs of the universe, vast hollows that occupy most of space itself. The galaxies and clusters we see, dazzling and dense, form only a fragile scaffolding on the edges of these voids, like the bright foam clinging to the surface of a deep black sea. To look into a void is to stare into the structure of the cosmos itself, the spaces between its bones. When astronomers first mapped the large-scale arrangement of galaxies, they expected something even and random, a kind of cosmic mist. But the map revealed a pattern, a delicate lattice known as the cosmic web. Galaxies weren't scattered evenly. They were strung together in immense filaments and walls, surrounding enormous empty regions like soap bubbles pressed together in a cosmic froth. In those dark bubbles, space is quieter, thinner, almost untouched. The largest of them, such as the Boötes void, span nearly 300 million light-years across. To travel through one would be to cross a desert so vast that entire superclusters would pass unnoticed before you reach the other side. These voids are not merely absences, they are essential to the universe's design. Matter flows away from them, pulled toward the denser regions by gravity. Over billions of years, the rich have grown richer galaxies gathering into clusters, clusters merging into filaments, while the voids have been drained, hollowed deeper by expansion. In a sense, they are the quiet result of cosmic evolution, the natural outcome of time itself, spreading matter unevenly through space. But they also raise profound questions about balance, symmetry, and what it means for something to exist at all. The universe, it seems, is not built from substance, but from contrast, the brilliance of light, defined by the dark that surrounds it. If you could drift through one of these voids, the experience would defy comprehension. The The stars would fade until only the faint glow of distant clusters remained, small and far away, like lanterns seen from the bottom of an abyss. The temperature would hover just above absolute zero, and the nearest atom might be meters away. You would not sense motion, because in a place without reference, movement has no meaning. The boundaries of the void would seem infinite, yet invisible, a realm of pure silence and slow time. Space there expands faster than in denser regions, stretching thin the fabric of reality itself. The farther you move, the more isolated you become, until even light begins to lose its way. And yet, even these voids are not truly empty. They hum with faint traces of dark matter and dark energy, the unseen components that make up most of the cosmos. Though we cannot observe them directly, their gravitational fingerprints shape the evolution of everything we see. Some cosmologists suspect that the voids may be where dark energy's influence is most pronounced, where the universe's mysterious acceleration first takes hold. It's as if the emptiness itself is alive, expanding and deepening the cosmic breath. The geometry of these voids, their subtle curves and distortions, offers hints about the universe's past. By studying how galaxies cluster around their edges, scientists can trace how matter moved after the Big Bang, how gravity sculpted the large-scale structure we inhabit. The voids act as windows into the primordial state of space, soft echoes of a time before galaxies, before light, when everything was smooth and silent. In their emptiness, they remember the calm before creation learned how to shine. But beyond their scientific meaning, the voids touch something emotional, even existential. They remind us that most of the universe is not stars or planets or glowing gas, it's absence. The cosmos is not a crowded room, but a cathedral of stillness, a staggering architecture of gaps and distances. We live on the thin walls between those hollows, fragile islands of matter suspended in an ocean of nothing, and yet, that nothingness is not meaningless. It gives the universe its shape, its rhythm, its breathing room. The voids are what make the galaxies possible, just as silence makes music possible. If we could see the whole universe from outside, we would not find a sphere of light, but a delicate web stretched across darkness, its beauty made visible only by contrast. The great cosmic voids are the spaces between those filaments, the quiet in the symphony, the pause between pulses of energy. They are as much a part of creation as the stars themselves, perhaps even more so, for within their emptiness lies the purest expression of the universe's nature, not endless fullness, but endless potential. And maybe that's the secret the voids are trying to tell us, that even in the coldest silence, something stirs, that the universe breathes through its emptiness, that creation doesn't end at the edge of light, it continues in the quiet, unseen spaces between. The great cosmic voids are not nothing. They are the vast canvas upon which everything is painted. In the beginning, the universe was young and restless, a storm of light and motion. Stars ignited, galaxies spun, matter clumped and scattered, and time itself seemed full of momentum. But nothing lasts forever, not even forever. Every act of creation spends its energy, every star burns through its fuel, and every particle of heat drifts from order toward stillness. Time, that relentless river, doesn't just carry us forward, it carries everything toward an end. Someday, far beyond imagining, that river will reach its final shore. The universe will exhale its last breath of warmth, and what we call time will begin to lose its meaning. The laws of physics tell us that everything tends toward entropy, the slow, inevitable spreading of energy until nothing remains to change or move or spark. It began innocently, with stars forming from clouds of gas, burning bright, and then dying into ash. Each death left behind remnants: white dwarfs, neutron stars, black holes, silent monuments to the brilliance that once was. Over trillions upon trillions of years, these remnants will fade too. The galaxies themselves will unravel as their stars exhaust their fuel, their light dimming until only cold embers remain. What began as an explosion of energy will end as an expansion of silence. Eventually, gravity will pull the last surviving stars into black holes, those dark hearts of space-time that consume everything near them. For a while, they will dominate the universe, giant engines of entropy, swallowing light and matter, converting the remnants of structure into perfect uniformity. But even black holes cannot last forever. They evaporate, slowly and imperceptibly, through a process called Hawking radiation, leaking their energy back into space across unimaginable spans of time. It will take 100 trillion years or more, but one by one, even those great cosmic anchors will dissolve, leaving only a sea of stray photons and ghost-like particles drifting through infinite darkness. When the last black hole vanishes, the universe will enter what physicists call heat death, a state of perfect stillness, where temperature, motion, and change no longer exist. There will be no stars, no planets, no galaxies, and no observers to witness their absence. Space will continue to expand, stretching thinner with every passing eon, while time marches on without anything left to measure it. In such a state, time becomes a word without meaning, because time requires change, and there will be none. The universe will not end with an explosion or collapse, but with a fading so complete it becomes indistinguishable from nothing. And yet, nothingness in physics is never truly nothing. Even in the vacuum, quantum fields tremble with possibility, producing brief, fleeting fluctuations, particles appearing and disappearing like thoughts in a sleeping mind. These ghostly ripples might continue forever, tiny sparks flickering in the dark, carrying the memory of a universe long gone. Some theories suggest that out of one of these fluctuations, a new Big Bang could occur, igniting a new cosmos from the ashes of the old. The death of one universe could be the birth of another, a cycle of endless beginnings and endings written into the fabric of existence itself. To think about the far edge of time is to step outside human scale entirely. Our lives, our histories, our civilizations, all of it happens in an instant compared to the universe's lifespan. Even the stars we call ancient are newborns in that vast chronology. And yet, it's comforting, in a strange way, to know that the story continues long after us. The atoms that make your body will one day drift through that deep future, their energy carried forward into new forms, perhaps even into new universes. Nothing is ever truly lost. It only changes shape, obeying the same laws that have guided every atom since the dawn of time. But there's another way to think about the end, not as a tragedy, but as a kind of peace. Entropy doesn't destroy meaning, it completes it. The heat death is the final stillness after an infinite symphony. Every note played, every echo faded into quiet. The universe will rest, not because it has failed, but because it has done everything it could do. Every star that burned, every atom that combined, every heartbeat that ever happened, they are all part of the grand expenditure of energy that time required. The silence that follows is not absence, it is fulfillment. And perhaps that silence isn't the end after all. Maybe the universe doesn't stop it, simply changes its language. Maybe time, as we understand it, dissolves only to reveal another form of being, one that doesn't need beginnings or endings. The equations that describe our world whisper of possibilities. We can't yet grasp dimensions beyond time, fields beyond decay, patterns that persist when energy itself seems gone. Perhaps in that final stillness, something eternal waits, like the quiet awareness between one breath and the next. If you could stand at the edge of time and look back, you would see the universe's entire life unfolding like a single wave rising, cresting, and falling into calm. You would see the galaxies as sparks, the stars as fleeting glimmers, the planets as passing dust. You would see that every moment, no matter how brief, was part of something vast and necessary. and you would understand that even the end is not truly the end. Time may fade, but the story never stops being told. It simply continues, quietly, beyond the far edge where light no longer reaches. Before the Big Bang, there was no light, no space, no time at least, not in the way we understand them. But that doesn't mean there was nothing. True nothingness, the complete absence of existence, may not exist at all. Beneath the calm surface of the cosmos lies a restless ocean, an invisible quantum sea that never truly sits still. Even in the coldest, darkest vacuum, where you might imagine silence and emptiness, the universe hums quietly to itself. Tiny fluctuations shimmer in and out of being, virtual particles appearing for the briefest flicker before vanishing again. This isn't an anomaly, it's the foundation of everything. The universe, it seems, was not born from nothing, but from the infinite potential of this quantum sea. Physicists call it the quantum vacuum, but the word vacuum is misleading. It suggests emptiness, a void free of energy or matter. In truth, it's the most active thing imaginable, a storm of creation and annihilation happening everywhere, all the time. Even when space seems empty, it teems with invisible activity, a perpetual dance of particles and antiparticles popping into existence and canceling out again. They live for such short moments that we cannot see them directly, but their effects ripple through the universe. These fluctuations create subtle forces, measurable shifts in energy that shape everything from the behavior of atoms to the evolution of galaxies. What we call nothing is, in fact, the deepest kind of something. Imagine space at the smallest scale, far smaller than atoms, smaller even than the particles that make atoms. There, the smooth fabric of reality dissolves into chaos. Space becomes turbulent and frothy, like the surface of a boiling sea. This is the quantum foam, a term coined to describe the unpredictable geometry of space-time at the Planck scale, where quantum mechanics and gravity collide. In that realm, space is not continuous but fluctuating, twisting and bubbling with transient forms. Miniature black holes blink in and out of existence. Wormholes open and close like tiny breaths. It's a landscape that defies intuition, where time may loop or fragment, and the idea of before loses its meaning. Some scientists believe the Big Bang emerged from such a sea. In that view, our universe was once just a quantum fluctuation, a ripple in the foam that inflated, stabilized, and became reality. If the laws of physics allow it, these fluctuations could happen eternally, spawning universe after universe in an endless cascade of creation. Each one would rise from the same restless background, expanding into its own dimensions, carrying within it the echo of that first trembling instability. In this sense, the universe didn't begin once, it's always beginning. This vision rewrites what we mean by creation. Instead of a single explosion from nothing, the birth of the cosmos may have been a natural event within an already vibrant quantum field, a moment when possibility became structure. The energy locked in the vacuum, the so-called vacuum energy, is not empty, but dense with potential. It can warp space-time, drive cosmic inflation, and maybe even give rise to entire realities. Some theories suggest that this vacuum energy is what continues to push the universe apart today, fueling its accelerating expansion. The same field that once birthed existence still hums beneath it, whispering quietly in every corner of space. If you could somehow stand inside that pre-cosmic sea, there would be no sense of place or time, no direction, no separation between this and that. You would be surrounded by infinite potential, a churning equilibrium of creation and destruction so perfectly balanced that it seems still. Every point would contain all possibilities. Every fluctuation could become a universe or could vanish before the idea of a universe ever took shape. The quantum sea is not chaos in the destructive sense, it is chaos in the generative sense, the fertile disorder from which order itself is born. And perhaps, in some strange way, this quantum foundation never went away. It didn't vanish after the Big Bang. It underlies everything that came after. Every atom, every photon, every heartbeat exists as a pattern on that original sea. The solid world we perceive, the stars, the air, the ground beneath your feet, is just the temporary crest of that ancient wave. When you strip everything down to its essence, the universe is still vibrating with the same restless energy that preceded time. Reality, it turns out, is less like a static object and more like a continuous process, a song still being played. It's difficult for the human mind to accept that nothingness is impossible. We crave beginnings, boundaries, explanations. But at the deepest level, the universe doesn't seem to need them. Existence, it appears, is its own default state. Even when stripped bare of matter and light, even when emptied of everything we call real, something remains, the underlying hum of potential, the quantum pulse of being. And maybe that's the ultimate secret. The void is not an absence to be feared. It's the origin of everything beautiful and strange. Before the first stars, before the first second, before even the first spark of time, there was the quantum sea, rippling silently beneath eternity. From that sea, the universe rose, and within it, everything continues to rise. Still the galaxies, the light, and the quiet awareness reading these words, all part of the same endless wave. We like to imagine the universe as a story with a clear beginning, a single spark that set everything into motion. The Big Bang, loud, luminous, definitive. But the more we study the cosmos, the less certain that story becomes. What if the universe didn't begin at all? What if the Big Bang wasn't the first chapter, but merely the latest page in a book with no true start or end? Some physicists now suspect that our cosmos carries faint memories of earlier worlds, echoes from before time as we know it began. The universe we see today is expanding. Galaxies drift apart, the fabric of space stretches, and the light from distant stars grows redder and fainter as it travels through the swelling void. This expansion has been happening for nearly 14 billion years, ever since that first great explosion. But if we trace it backward, if we let the galaxies collapse inward in our imagination, we reach a moment of infinite density, a single point where the laws of physics break down. That's the Big Bang, the moment of origin. Except, the deeper we look, the more it starts to look less like a beginning and more like a transition. One idea, proposed by the physicist Roger Penrose, suggests that the universe may move through endless cycles of birth and death, called aeons. Each aeon begins with a Big Bang and ends in a long, slow fade. Over trillions of years, galaxies exhaust their stars, black holes evaporate, and the universe becomes smooth and empty, a vast field of almost featureless radiation. In that final state, when all structure has vanished and all differences have dissolved, the universe becomes, paradoxically, scaleless. With no clocks to measure time and no matter to define distance, the concept of size loses meaning. And in that strange condition, Penrose suggests, the end of one universe can transform seamlessly into the beginning of another. The infinite future of one cosmos becomes the first instant of the next. It's a bold idea that time loops, that creation and destruction are part of the same continuous rhythm. But if that's true, then traces of previous aeons might still linger within our own. Penrose and his collaborators have searched the cosmic microwave background, the oldest light we can see, the soft afterglow of the Big Bang, for circular patterns that could be the fingerprints of ancient events. These Hawking points, as they're called, would be subtle bruises left by supermassive black holes evaporating in a prior universe. Each one, if real, would be a message from a cosmos long gone, encoded in the radiation that still wraps around us like an ancient echo. So far, the evidence is tantalizing but uncertain. Some scientists argue that these patterns are real and statistically significant. Others say they're coincidences, artifacts of noise in the data. But the mere possibility reshapes how we think about everything. It means that our universe could be part of an eternal chain, each cycle giving birth to the next in a graceful handoff of entropy and energy. The Big Bang would no longer be a beginning, but a bridge, one universe dying into another, its ashes lighting the next creation. There are other cyclical models too, each with their own variations. Some propose that the universe expands until gravity pulls it back inward, collapsing everything into a big crunch, followed by another explosion, a big bounce. Others imagine a multiverse of bubbles, where each collision between universes triggers a new burst of expansion. In every version, there's the same haunting implication. Creation is not a one-time miracle, but a repeating pulse, the heartbeat of an infinite cosmos. If that's true, then everything, every star, every breath, every thought has happened before, in some form, maybe not identically, but in echo. The atoms that make up your body might have existed in another universe entirely, drawn into another pattern, another story, before finding their way here. The universe remembers, even if it doesn't repeat exactly. The background radiation that fills our sky could be a kind of cosmic memory, a faint chorus from worlds that burned long before ours began. There's something deeply human about wanting a beginning, a moment we can point to and call the start of everything. It gives us comfort, a sense of order, a way to define meaning. But the universe, vast and patient, may not obey such neat lines. It may flow in cycles, each ending feeding the next, like waves breaking and reforming upon an endless shore. Time itself might be circular, looping back upon its own tail, erasing the difference between before and after. And if that's the case, then nothing is truly lost. Every collapse becomes a seed, every silence becomes potential, every death becomes a beginning in disguise. The cosmos, it seems, might be immortal, not in the sense of never-ending, but in the sense of always beginning again. So perhaps the Big Bang wasn't the start of everything, but the echo of a universe that came before. Perhaps somewhere, written into the faint hiss of background radiation, are the final sighs of a cosmos that lived and ended so that this one could rise. And perhaps, one day, when this universe fades into quiet light, it too will leave behind its echo, an invisible ripple whispering across eternity, waiting to bloom again. Long before telescopes and quantum fields, before we could even name the stars, there was math. Not the arithmetic of daily life, but something older and stranger, the quiet order that seems to hum beneath everything. The planets trace perfect ellipses, crystals grow in symmetrical lattices, music resolves into ratios and harmonies that please the ear because they echo patterns written into nature itself. Everywhere we look, the universe appears to speak a language of numbers. But what if it doesn't just speak mathematics? What if it is mathematics? What if reality itself is a structure made not of particles or energy, but of relationships, equations, and patterns existing in an abstract, timeless realm? The idea isn't new. The philosopher Plato imagined a world beyond the physical, a domain of pure forms, perfect and unchanging, of which our world is merely a shadow. To him, a circle wasn't the line we draw in sand or ink, but the ideal circle that exists beyond imperfection, beyond time. Modern physicists and mathematicians have extended that thought further, suggesting that perhaps everything that exists does so because it corresponds to a mathematical structure. In other words, the universe isn't described by math. It is math. Every particle, every law, every constant is simply a node in a grand numerical web. This is known as the mathematical universe hypothesis, proposed by cosmologist Max Tegmark. It suggests that all mathematical structures exist as physical realities in their own right. Each consistent set of equations defines a universe, some simple, others complex, many unimaginable. In this picture, our cosmos is just one mathematical object among infinitely many, one solution among countless possible realities. Somewhere, There might exist a universe governed by equations entirely unlike ours, where space has different dimensions, where time flows in spirals instead of lines, where consciousness takes forms we couldn't begin to conceive. The multiverse, under this view, isn't a physical space filled with other universes. It's an infinite landscape of mathematical truth, every possible pattern existing eternally, waiting to be perceived. It's a dizzying thought, one that challenges what we mean by real. When we write an equation like E equals mc squared, we think of it as describing how our universe behaves. But what if that equation itself is the thing that exists, and the physical world we see is merely its manifestation? Matter, energy, and motion could all be expressions of relationships between numbers, like melodies arising from notes on a scale. The atoms that make up your body might be nothing more than stable solutions in a cosmic equation, harmonies in the mathematics of being. If this is true, then even consciousness might be a mathematical pattern, a particular arrangement of information capable of reflecting upon itself. You, reading these words, would be a momentary configuration within an equation so vast it encompasses stars and galaxies. And if every consistent mathematical structure exists, then there could be other conscious beings inhabiting entirely different forms of mathematics, beings for whom our physical laws are as alien as theirs are to us. The universe would not be the exception but the rule. Every possible set of mathematical relationships would correspond to some kind of existence, somewhere in the grand infinity of all structures. There's a strange comfort in this view. It means that the universe doesn't need a reason to exist. It exists because it can exist. Anything that can be expressed consistently in mathematics must, by definition, exist somewhere in that infinite landscape. Existence becomes a matter of logic, not creation. In such a reality, the line between imagination and physics dissolves. When we discover a new mathematical truth, we are not inventing it. We are uncovering another corner of the eternal, another world that was always there, hidden in the structure of possibility. But there's also something haunting in it. Mathematics is cold, precise, and absolute, untouched by emotion or meaning. If reality is purely mathematical, where does wonder fit? Where does love, beauty, or longing belong in a world of equations? Perhaps those things too are patterns, emergent harmonies that arise naturally when certain structures evolve. Beauty might simply be the resonance of one part of the mathematical fabric recognizing itself in another. Meaning could be the experience of symmetry within consciousness, the mind's way of aligning with the universe's logic. And yet, even in this austere view, there is poetry. To think that existence itself could be written in numbers is to realize that every breath, every heartbeat, every galaxy and atom is part of an infinite, perfect geometry. The laws of motion, the curve of space-time, the rhythm of waves against the shore, all of it is one vast, coherent structure, humming in patterns beyond comprehension. Reality isn't random. It's elegant, precise, and alive with the pulse of logic that never ends. Perhaps the greatest mystery, then, is not whether mathematics describes the universe, but why we creatures born of dust and breath can understand it at all. Somewhere inside our minds, the universe's equations find their reflection. We discover them not as outsiders, but as participants, as fragments of the very structure we are trying to comprehend. When you trace a line of reasoning, when you glimpse the symmetry in an equation and feel that quiet awe, you are looking at reality recognizing itself. And maybe that is what it means to exist in a mathematical universe. We are not separate from it, not visitors wandering through a foreign system of rules. We are part of the equation, part of the pattern, part of the infinite logic that gives rise to everything. The universe is not made of matter or energy, but of meaning woven in numbers, sung in symmetry, alive in every form that can ever be. Imagine standing in front of a hologram, a flat image that somehow holds the illusion of depth. You move your head, and the picture shifts, revealing new angles, new perspectives, as though a three-dimensional world were hidden inside a two-dimensional surface. It's an elegant trick, one that feels almost magical. But what if the entire universe works the same way? What if everything you see, everything you feel, every star, every atom, every heartbeat is not happening in the vast interior of space, but is instead the three-dimensional projection of information encoded on a distant cosmic boundary? This is the essence of the holographic principle, one of the strangest and most beautiful ideas in modern physics. It began not with fantasy but with a paradox, one born in the heart of a black hole. According to general relativity, when something falls into a black hole, its information, the detailed blueprint of its structure, should be destroyed. But quantum mechanics forbids that. Information, it insists, can never be lost. Physicists struggled with this contradiction for decades, until a discovery by Jacob Bekenstein and Stephen Hawking hinted at a solution. They found that the amount of information a black hole can contain isn't proportional to its volume, as one might expect, but to the area of its surface, the event horizon. The information about everything that has fallen in seems to be stored on that two-dimensional boundary, like patterns etched on a cosmic skin. That revelation changed everything. If black holes store their information on their surfaces, perhaps the universe itself works the same way. Perhaps our three-dimensional reality, the world we walk through, the galaxies we observe, is just a holographic projection of information written on the universe's farthest boundary. In that picture, the cosmos is like a grand hologram, where every detail of space, time, and matter arises from a deeper, hidden layer of information spread across a cosmic screen. It's a staggering thought, because it suggests that the reality we experience as solid and deep might be fundamentally flat. Every particle, every field, every motion could be the shadow of quantum information playing out on the distant edge of space-time. The universe, in this sense, is both infinite and encoded a film of data, expanding with time, replaying itself in the illusion of three-dimensional depth. The mathematics supporting this idea began to crystallize in the 1990 seconds through the work of Juan Maldacena, who proposed a duality known as the adds divided by CFT correspondence. In simple terms, it suggested that a universe governed by gravity in 3 dimensions could be fully equivalent to a universe without gravity in 2 dimensions. Everything happening in the bulk of space could be perfectly mirrored by equations defined on its boundary. Gravity, matter, energy, all of it might emerge from patterns of information inscribed on that distant edge. Our universe, then, could be a kind of cosmic hologram, with the boundary as the original film and everything inside as the projected illusion. If that's true, it forces us to rethink what it means to exist. We like to think of ourselves as beings moving through space, but maybe space itself isn't fundamental. Maybe it's the byproduct of information interacting with itself in complex ways, giving rise to the geometry we perceive. The distance between stars, the passage of time, even the sense of volume you feel when you take a breath. These could all be emergent illusions woven from the language of information. The universe would not be a stage where events occur, but an intricate pattern of relationships continuously unfolding from its encoded foundation. The holographic principle also offers a strange kind of unity. If everything inside the universe is encoded on its boundary, then every object, every event, every life is already written into the fabric of the cosmos. The stars burning billions of light years away and the thoughts flickering in your mind are part of the same grand inscription projected into the same luminous field. It means that somewhere, on the edge of time, the entire story of the universe exists in a single pattern, complete, interwoven, and eternal. And yet, within that pattern, something mysterious happens, the illusion of freedom, of movement, of newness. We experience the projection as life, as motion, as unfolding time. The hologram is not static, it breathes, evolves, and expands. Just as the light in a holographic image seems to shimmer with depth, our universe shimmers with the feeling of reality. The illusion is perfect, so perfect that it becomes indistinguishable from truth. It's tempting to imagine that this idea makes the world less real, that it reduces existence to code on some distant surface. But perhaps the opposite is true. Perhaps it reveals that reality is deeper than we can perceive, that the physical and the informational, the seen and the unseen, are one and the same. A hologram is not a lie. It's a different way of encoding truth. The projection doesn't diminish the image, it gives it life. So when you look at the night sky, when you see the stars blazing against the dark, you might be looking not into an endless abyss, but into the inner glow of a cosmic hologram light, streaming from information etched on the edge of everything. And in that reflection, you are there too, written into the same luminous field, a ripple in the code that gives rise to space, to time, to wonder itself. There is a limit woven into the universe, a boundary that everything we know obeys. Nothing, we are told, can move faster than light. It is not just a speed, it is the speed, the limit that defines cause and effect, before and after, here and there. Light is the cosmic rule keeper, and time itself dances to its rhythm. Yet, when we look closer, when we begin to imagine what might lie beyond that limit, the rules start to tremble. Because beyond light, the very concepts of distance and duration begin to dissolve. And if those dissolve, what remains? For more than a century, Einstein's theory of relativity has told us that nothing can outrun light, because as an object approaches that speed, its energy demand becomes infinite, its mass grows without bound, and time slows to a crawl. But equations are strange things. They often whisper secrets the universe hasn't yet revealed. Within those same equations hides the possibility of something extraordinary, particles that always move faster than light. Physicists call them tachyons. They are hypothetical, never detected, perhaps impossible, and yet their existence lingers like a rumor at the edge of physics. If they exist, they would not experience time as we do. To them, all of history might appear at once, the past and future folded together into a single, motionless landscape. Where we see sequence, they might see symmetry. Where we crawl from birth to death, they might exist outside that line entirely. In a world of tachyons, cause and effect blur. Messages could, in theory, travel backward in time. A signal sent today could arrive yesterday, or long before the sender was even born. This is the kind of notion that bends the mind into knots. But what's more interesting is what it suggests about the fabric of reality itself, that time may not be fundamental. It may be an emergent property, something that arises only within our slow, light-bound corner of the cosmos. Outside it, there may be no before or after, just a boundless present, still and infinite, where everything simply is. This idea grows even stranger when we add quantum theory into the mix. Quantum mechanics tells us that particles can tunnel through barriers, exist in multiple states at once, and communicate instantaneously across vast distances, defying the limit of light. These effects don't mean that information truly travels faster than light, at least not in a way we can use, but they hint that space and time themselves might be illusions, approximations of something deeper. Beneath the smooth surface of space-time, reality might not be continuous at all, but made of discrete units, tiny grains of information, where the notions of speed and distance lose their meaning. In such a landscape, asking what lies beyond light would be like asking what lies north of the North Pole. Beyond light might not be somewhere else. It might be a different kind of existence entirely. Negative energy adds another twist. It's not just a theoretical curiosity, it shows up in quantum fields, in the Casimir effect, even in models of black holes and wormholes. Negative energy is strange because it can, in principle, bend space-time in the opposite direction of gravity. While normal matter attracts, negative energy repels. Some physicists speculate that if we could harness it, We might create shortcuts through space-time wormholes that link distant regions, or even loops that circle back through time. In that picture, beyond light doesn't mean outrunning photons. It means folding the universe so that distance itself becomes irrelevant. It's possible that the edge of reality isn't out there among the stars, but here, in the boundaries of perception and the limits of our models. Light and time are the scaffolding we use to make sense of existence, but maybe they're only the visible part of something larger, something that doesn't unfold in sequence, but exists all at once, like a book written in a single word, too vast for us to read. We are trapped inside the flow of time, carried along by the current, unable to step outside the river to see its shape. But perhaps, to whatever exists beyond that flow, the whole river, past, present, future, is already complete. The notion that space and time are illusions sounds mystical, but it arises naturally from physics. In general relativity, space and time can warp and stretch. In quantum mechanics, they can blur. When the two theories meet at black holes, at the Big Bang, at the smallest scales, space-time seems to unravel. The equations don't break because the universe stops. They break because our concept of universe no longer applies. There may be no outside to reach, no higher place to stand. The distinction between what's inside and what's beyond could be one of perspective, not location. And maybe that's what lies beyond light and beyond time, not a destination, but a realization. That the universe is not moving towards something. It's already everything it can be. Every photon that has ever traveled, every second that has ever ticked, every life that has ever unfolded, they all coexist in a single, timeless whole. We move through it like shadows across a painting, mistaking motion for progress, sequence for truth. If you could step outside of time, if you could look at the universe without the filter of speed or causality, perhaps you would see it as it truly is, a complete pattern, infinite and motionless, humming with everything that ever was and ever will be. Beyond light, beyond time, there may be no edges, no directions, no beginning or end. Only the quiet symmetry of existence itself, unchanging, eternal, and whole. When you open your eyes, light from the universe enters them, photons that have traveled for billions of years, some born in the hearts of stars, some scattered from the first flash of the Big Bang. They touch the surface of your retinas, trigger electric signals, and in an instant become perception. You see. But what does it mean for the universe to be seen? For so much of physics, observation is treated as an afterthought, something separate from the machinery of reality. Yet the deeper we look, the harder it becomes to separate the observer from the observed. The act of looking, somehow, seems to shape what is seen. In the strange world of quantum mechanics, this mystery becomes unavoidable. Subatomic particles don't behave like tiny billiard balls moving along definite paths. They exist in states of probability, waves of possibility, until something measures them. Only then does the wave collapse into a single outcome, a single reality. The double-slit experiment is the simplest, most haunting example. When particles like electrons pass through two slits without being observed, they behave like waves, forming an interference pattern. But when we watch, when we place a detector to see which slit each electron passes through, that pattern vanishes. The electrons act like particles instead, as if they know they are being observed. This doesn't mean human consciousness is magically shaping the universe, but it does raise a deeper question. What is an observation? At the quantum level, looking isn't about eyes or awareness. It's about interaction, about information being exchanged. Still, the fact remains that reality only settles into specific states when measured. Before that, it exists as a haze of potential, a cloud of maybes. Some physicists interpret this to mean that the universe does not have definite properties independent of observation. Others argue that it does, but we can only ever access one thread of it. Either way, the observer is entangled with the observed. We are participants, not spectators. It's easy to dismiss this as a quirk of the microscopic world, far removed from the cosmic scale. But when you think about it, the principle stretches all the way up. The universe has no meaning without something to experience it. Galaxies spin, light travels, stars are born and die. But none of that becomes reality in any experiential sense until there is something capable of perceiving it. Perhaps consciousness, in all its mysterious forms, is the universe folding back upon itself, aware of its own patterns. In us, the cosmos looks inward. There is a quiet poetry in that idea that every conscious being, no matter how small, is a fragment of the universe, observing its own existence. When you gaze at the stars, you are literally a piece of the cosmos, becoming aware of its vastness. The atoms in your body were forged in stellar furnaces. The calcium in your bones once blazed in the heart of a dying sun. The iron in your blood was born in the explosion of a star that ended its life so that new worlds could begin. The universe evolved matter, then life, then mind, and through that mind, it learned to look back at itself. But if observation gives shape to reality, what happens at the edges where no one can look? Beyond the limits of our telescopes, beyond the light that has had time to reach us, the universe continues in silence. Entire galaxies drift in darkness, unseen and unmeasured. Do they exist in the same sense as the stars we can see? In a way, this question isn't just about astronomy. It's about the very nature of being. Does existence require witness? Does the cosmos need consciousness to crystallize from the sea of possibility into the form we experience? Some interpretations of quantum theory suggest that the universe itself, through its own internal interactions, acts as its own observer. Every exchange of energy, every photon absorbed, every collision of particles counts as a kind of measurement, a way of the cosmos registering its own state. In that view, consciousness is not the creator of reality, but its refinement, the point at which the universe becomes self-aware enough to reflect. Awareness is what happens when matter becomes complex enough to echo the structure of the whole. We are, in essence, the universe watching itself happen. Still, the mystery remains. Consciousness, like light, resists being pinned down. We can describe its neural correlates, map its patterns, simulate its processes, but not explain its essence. It is the one thing we know most intimately, and yet the hardest to define. Perhaps that's because it isn't a property of brains alone, but of reality itself, an inherent potential of the cosmos, awakening wherever complexity allows. If so, then every mind, every flicker of awareness across space and time is part of one continuous field of knowing that began with the universe itself. To think of the universe as an observer is to see existence not as a cold machine, but as a kind of living mirror. The galaxies, the stars, the black holes and voids, they are all expressions of the same vast unfolding that gave rise to thought, curiosity, and wonder. The universe doesn't just contain consciousness, it creates it, depends on it, and perhaps is it in some unfathomable way. And so, when you look out into the night sky, you are not a tiny thing gazing into something vast and indifferent. You are that vastness, aware of itself for a fleeting moment, looking back across eternity. The stars are not distant, they are within you, reflected in the same fabric that holds your thoughts. The universe observes itself through your eyes, and through that act of looking, reality becomes real. If you were to start zooming out from the Earth past the clouds, past the curve of the planet, past the glimmering shell of satellites, and the cold silence of the moon, you would begin to see patterns. The Earth is part of a solar system, the solar system part of a galaxy, the galaxy one of trillions suspended in a vast web of filaments and voids. But what if that structure never ends? What if, no matter how far you travel outward, the pattern simply repeats galaxies, forming the atoms of some even greater cosmic organism, which itself is a small fragment of something larger still. The deeper we look into the universe, the more it resembles a fractal, a self-repeating pattern without end, where the same shapes appear at every scale. Fractals are nature's hidden language. We see them everywhere once we learn to look. The veins of a leaf, branching like the tributaries of a river, the spiral of a seashell, mirroring the curve of a distant galaxy, the delicate geometry of snowflakes echoing the patterns of crystal growth in mineral veins deep underground. Each is an expression of the same principle, the repetition of form within form, order emerging from complexity. The universe seems to favor this recursive beauty, building vastness from simplicity. Even the network of neurons in the human brain mirrors the structure of the cosmic web, filaments of matter connecting like synapses in a galactic mind. It is as though the universe cannot help but imitate itself. When astronomers map the cosmos, they find that galaxies are not scattered randomly, but arranged in a vast web-like structure, connected by threads of dark matter spanning hundreds of millions of light years. These threads form clusters and superclusters, separated by enormous voids where almost nothing exists. On maps, this cosmic web looks astonishingly familiar. It resembles the branching of lightning, the roots of trees, even the growth of frost on glass. It's a pattern that repeats in biology, chemistry, and physics. Different scales, same rhythm. And so the question arises, does it ever stop repeating? Is there an upper limit to the pattern, or does the universe continue fractaling forever into realms beyond our comprehension? If the universe is infinite, then perhaps it contains structures larger than any we can imagine, systems of superclusters forming new, grander patterns that stretch beyond our cosmic horizon. To us, they would be invisible, because light from those distances has not had time to reach us. But that doesn't mean they aren't there. Our observable universe might be just one small cell in a cosmic organism so vast that its full body spans beyond the reach of time itself. And if this recursive structure continues outward without end, then what we call everything is just a single layer in an endless nesting of realities. It's possible, too, that the pattern repeats inward as well as outward. The particles that make up atoms might have their own internal universes, bound by their own physics, their own space and time. Some theories of quantum gravity even suggest that space-time itself could have a fractal nature, that the closer we look, the rougher and more intricate its structure becomes, repeating infinitely down to scales smaller than we can ever measure. In that sense, zooming in and zooming out might be the same act viewed from different directions. The micro and the macro might not be separate at all, but reflections of one another, like mirrors facing each other across infinity. If this fractal nature is true, then the universe is not just vast, it is recursive, a pattern aware of itself through repetition. Each level might contain echoes of all others, as though reality is a song with infinite harmonics. When you look up at the night sky, you might be seeing a pattern that repeats endlessly, each repetition a little different, but still bound by the same underlying rules. Every cluster of galaxies could be a single point in a larger design. Every particle could contain within it the blueprint of all existence. The universe would not be expanding into nothing, it would be unfolding into itself. There is something profoundly humbling about this possibility. It suggests that our place in the cosmos is neither central nor insignificant, but recursive. We are both the pattern and part of it. The same geometry that governs the distribution of galaxies shapes the branching of our lungs, the flow of rivers, the growth of coral, and the firing of neurons that let us wonder about it all. The universe seems to be made of echoes of patterns repeating in matter, in energy, in thought. If you could somehow step outside of scale itself, if you could see the universe not as big or small, but as structure, you might find that it folds back upon itself endlessly, like an infinite tapestry woven from its own image. There would be no edge, no end, no final level where the pattern stops. Each layer would give rise to the next, and somewhere within that recursion of consciousness, this very moment of awareness would be just another repetition, another reflection of the same eternal geometry. Perhaps that is what lies beyond the edge of the universe. Not a border, but more universe, more pattern, more self-similarity stretching into forever. The cosmos may not be a story with boundaries, but a fractal dream of itself repeating endlessly, beautiful in every scale, a reflection that has no beginning and no end. The universe is not still. Even now, in the darkness between galaxies, in the quiet places where no light has ever reached, space is stretching. The fabric of reality itself expands, not just carrying galaxies apart, but creating more space between them as it does. This expansion has no edge, no center, no boundary to push against. It simply happens everywhere at once. And if the theories are right, it may never stop. The universe may be infinite, not only in size, but in time, an endless unfolding where new universes are born while others fade, an eternal bloom of creation. Physicists call it eternal inflation. It began with the Big Bang, or rather, with the moment before it, the inflationary epoch, when the universe grew from smaller than an atom to cosmic size in a fraction of a second. That brief surge didn't happen once, but could be happening still, in other regions beyond our view. Inflation, like a fire spreading across a field, may never completely burn out. Each patch of space that stops inflating becomes a universe, like ours, cooling and coalescing into galaxies, stars, and life. But beyond it, the rest of the cosmic field keeps expanding, faster and faster, spawning more universes like bubbles in an endless sea. In this vision, the multiverse is not a poetic metaphor, it is the natural consequence of physics. Each universe that emerges might have its own laws, its own constants, its own version of time. Some may last an instant, collapsing back into the void. Others may expand for trillions of years. Ours is just one bubble in a vast cosmic foam, drifting through an ocean that will never stop churning. Somewhere, right now, new Big Bangs may be unfolding, entire realities bursting into existence in silent brilliance. The birth of a universe is not an event that happened once long ago. It's happening forever, everywhere. If eternity sounds peaceful, it isn't. Beneath this vast, ongoing creation lies instability. The vacuum of space, the fabric that holds reality together, might not be the ultimate ground state of existence. It could be what physicists call a false vacuum, a temporary, fragile plateau of stability. In that case, all of space is like a glassy surface stretched thin over a deeper, truer energy state. Sooner or later, somewhere in the infinite expanse, a quantum fluctuation could trigger a collapse, a tiny bubble of lower energy vacuum forming within our own. That bubble would expand at the speed of light, rewriting the laws of physics as it went, obliterating everything it touched. We would never see it coming. The end would arrive faster than thought. But before fear has time to take hold, consider this. It might already have happened somewhere far beyond us, countless times, in universes where the conditions were just right. And yet, here we are, still existing, still breathing, still watching the stars. This suggests something profound, not that we are safe, but that creation and destruction may be inseparable. Every act of collapse could be the seed of another universe. The vacuum decays, and from that decay, new space-time blooms. What we call the end might be another beginning, invisible from here, but inevitable across the boundless reach of forever. To imagine eternal inflation is to imagine a reality that never pauses. Somewhere, new stars are igniting while others die. Somewhere else, time itself has only just begun. The totality of existence becomes a kind of cosmic fractal in time, each universe a petal on an infinite flower, each bloom giving rise to others endlessly. There is no single moment of creation. There are infinite moments, all coexisting, all layered within the same vast field. And in that sense, even this very instant, the one in which you are reading these words is connected to the birth of countless other worlds. We live in one bubble, one story, but the foam around us may stretch beyond measure. And though we can never reach those other universes, their presence might still ripple through ours. The faint uniformity of the cosmic microwave background, the slight irregularities in its glow, may carry whispers from that inflationary sea, a record of fluctuations that happened before our universe was even born. These are the fingerprints of forever, written into the light that fills the night sky. It is strange, almost comforting, to think that creation doesn't end. Even as the stars in our universe will someday fade, even as time stretches toward heat, death, and silence, the process that began everything continues elsewhere. In some far region of the multiverse, another sky is forming, another world taking shape, another kind of life, perhaps beginning to open its eyes. Eternity is not an endless line, but an endless flowering, each moment a new petal unfolding from the last. And so, while we drift toward sleep, our small corner of existence cooling into stillness, the larger cosmos goes on creating itself, wave after wave, forever. The field never stops. The vacuum hums with potential. Somewhere, universes are being born right now, silent, luminous, expanding into their own infinity. Perhaps eternity has no beginning and no end because it never needed one. It simply is, always becoming, always new. If there are other universes, they are not near in any ordinary sense. They do not float beside us like neighboring galaxies or linger just beyond the range of our telescopes. They exist in realms where the word distance has no meaning, separated not by space, but by the fabric of existence itself. Between them lies a gulf that cannot be crossed, a silence deeper than anything we can imagine. These are the spaces between realities, the untouched corridors of the multiverse, if such a thing truly exists. And if it does, then somewhere beyond our cosmic horizon, another universe may be unfolding right now, its own stars burning, its own laws of physics singing a melody we can never hear. When cosmologists speak of the multiverse, they often describe it as a sea of bubbles. Each bubble is a universe, expanding into its own space, born from its own Big Bang. Inside each one, time flows forward, galaxies form, life may rise and fade, and yet no bubble can ever touch another. The boundaries between them are not surfaces we could reach or walls we could touch. They are regions of such immense energy and difference that the rules of our reality no longer apply. The physics that governs our atoms could dissolve at that edge, erased by the infinite inflation of the vacuum between. Even if two universes brushed together for an instant, the violence of that meeting would unmake everything in both. It would not be a merging, but an annihilation. And so the universes drift, eternally apart, their boundaries expanding into silence. In that silence, time does not pass, not in the way we know it. Time is born inside a universe, carried by the expansion of space and the movement of energy. Between universes, where no energy flows and no clocks can tick, there is no before or after. There is only stillness, a stillness so complete that even eternity becomes meaningless. It is not emptiness, because emptiness is still a state of something. This is the absence of even that a nothingness, untouched by matter, energy, or memory. If there is a place where the multiverse breathes, it is in these silences. The spaces between bubbles are the dark lungs of creation, where inflation never stops, where potential exists without expression. Within that nothing, universes are born, expanding and cooling, spinning their own versions of reality into being. But once born, they are gone from each other forever. The silence closes behind them, sealing the boundary. Every universe is an island, surrounded not by water or air, but by the void beyond existence. There are theories that suggest these boundaries might leave scars. If two universes collided in the early moments of inflation, The impact could have left imprints, subtle distortions in the cosmic microwave background, faint ripples frozen in the afterglow of creation. Some scientists have searched for them, hoping to glimpse a fingerprint of another cosmos pressed faintly against our own. So far, the sky has offered no proof. The microwave background is smooth, the silence unbroken, but even that smoothness carries its own kind of meaning. It suggests that if other universes are out there, they are forever beyond our reach, cocooned in isolation so perfect that no light, no sound, no signal could ever cross the divide. To imagine that silence is to imagine the purest kind of stillness. It is not peaceful in the human sense. There is no sound to soothe, no calm to feel. It is not a resting place, but an absence of place itself. Even the word silence is too small. It implies an ear to hear it, a consciousness to register its depth. In the void between universes, there is no such witness. There is only potential without presence, only the frozen pause between creation and oblivion. And yet, within that silence, everything begins. The quantum field that underlies existence still hums faintly there, restless and infinite. It is from that hum that new universes are born, each one igniting from the nothing, expanding into its own laws and dimensions. The silence between universes is not dead, it is pregnant. It waits without waiting, existing without being, until some random fluctuation stirs, and a spark becomes a new reality. In that way, the void is both nothing and everything, the womb and the tomb of all creation. If we could ever peer into that in-between, we would see no light, no movement, no horizon. We would see only the impossibility of sight itself. We would witness a stillness so vast that the mind could not survive it. But perhaps, if we could feel it rather than see it, it might not seem terrifying at all. Perhaps it would feel like rest, a kind of cosmic pause, the quiet breath the multiverse takes between endless acts of becoming. And maybe, after all, that is what forever truly is, not an endless stream of time, but the space between moments, the silence between universes. While one reality burns bright with stars and life, another sleeps beyond reach, and between them stretches that infinite hush. It is there now, surrounding us from the outside, waiting patiently as it always has, the great stillness that holds all worlds apart, yet binds them in the same eternal silence. The edge of the universe is not where space runs out. It's not a line beyond which there is nothing, nor a border where galaxies end and darkness begins. The true edge is quieter, closer, hidden in plain sight. It lives inside you, in the folds of your thoughts, in the stillness between your heartbeats. The same atoms that once burned in ancient stars now sit in the rhythm of your pulse. The same energy that shaped galaxies hums softly beneath your skin. You are not outside the universe, looking in. You are the universe, looking at itself, trying to understand its own reflection. Every element of your body has traveled across eternity to be here. The carbon that builds your cells was forged in the heart of a long-dead sun. The calcium in your bones was once part of a collapsing star's core. The iron that carries oxygen through your blood came from a supernova's final breath. You are made of the ashes of stars, of cosmic dust, of everything that has ever been. And yet, somehow, that dust learned to wonder, to imagine what lies beyond its own horizon, to name itself I. We search for the universe's edge as if it were something distant, unreachable, mapped in coordinates and light years. But what we call the edge may be an illusion, a reflection of the limits of our perception, not of reality itself. The observable universe ends where light has not yet had time to reach us, but beyond that, there may be endless worlds, unseen and unknown. In the same way, the boundary of your awareness is not the limit of what exists within you. There are thoughts you will never think, dreams you will never recall, mysteries in your mind, deeper than memory. The cosmos outside and the consciousness within both stretch into infinities that refuse to be measured. Perhaps this is no coincidence. Perhaps the structure of the universe and the structure of awareness are mirrors of one another, built from the same fabric. Neurons branching like galactic filaments, synapses flickering like stars, electrical storms of thought echoing the dance of cosmic radiation. When you gaze at the night sky, it is not just matter observing matter, it is awareness, observing awareness, the universe folding back upon itself in an endless act of recognition. This connection is more than poetry, it's physics. The same laws that shape the birth of galaxies govern the chemical reactions in your brain. Quantum fields vibrate within you the same way they vibrate through interstellar space. The energy that fuels your body is the same energy that lights the stars. You exist because the universe needed a way to feel its own beauty, to question its own design, to dream of its own beginnings and endings. Consciousness may not be a byproduct of the cosmos, it may be its continuation. If you could step outside of your own awareness, as impossible as that is, you might see it the way you see the night sky. Vast, glowing, mysterious, filled with patterns and unknowns. There would be regions of brightness where thought and memory cluster like galaxies, and there would be voids, dark regions beyond the reach of your own understanding. And, like the cosmos, your mind is still expanding. Every moment of reflection, every act of curiosity, every quiet breath of wonder stretches that inner universe a little farther, bringing more of yourself into light. It's tempting to think of the cosmos as cold and indifferent, but it cannot be, because you exist within it, and you are not indifferent. You care, you love, you hope, you fear, all of which means the universe does too, through you. You are its awareness made manifest. The edge of the universe is not a physical boundary. It is the threshold where experience meets the unknown, where the infinite looks inward and becomes a question. You stand at that threshold every time. You think, every time you look up at the stars, every time you ask, what else is out there? And maybe, if you listen closely enough, you can feel it, that soft hum beneath everything, the quiet pulse that runs through galaxies and hearts alike. It is not just the sound of existence, it is the rhythm of connection. The reminder that everything you are was once part of something unimaginably vast, and still is. When you breathe, you are inhaling the residue of ancient starlight. When you dream, you are touching the oldest mystery of all, the universe wondering about itself. So perhaps the edge you've been seeking isn't distant or unreachable. Perhaps it has always been inside you, waiting to be recognized. The horizon of awareness, the thin line where thought meets infinity. Beyond it, there are no borders, no endings, no separate worlds, only the unbroken whole matter and mind, starlight and silence, the outer vastness and the inner depth, one and the same. The universe does not end where your sight fails. It ends only where your wonder does. And as long as you keep asking, as long as you keep looking inward and outward with equal awe, that edge will never come. It will only recede, forever inviting, forever expanding, forever whispering the same quiet truth. You are part of everything, and everything is part of you.